Okay. This is the estimate the sample size worksheet portion. And when we're going to estimate the sample size, it's going to be because we're going to perform a new study. So we want a new study, and we don't want to waste any time by gathering data, extra data that's not needed. So time is money, and if you spend all this money and time gathering more data values than you need to be within a particular margin of error that you might be interested in, it's a waste of time, it's a waste of resources. So we want to estimate the sample size first for a new study. And we say that here. We say when conducting a new study here, and we're going to estimate a population parameter, it is ideal first to determine the minimal sample size. You want to find the minimal sample size n needed for the study. And so as we've seen here, these formulas all are about sample size, n. And they all came from using or solving the margin of error formulas for the variable n using algebra. So what I'm going to say here, if your new study involves, you're going to estimate a proportion. And that's why they have the phrase here, proportion. That's what formula you're going to use when the sample proportion is known, and that is known from a past study. So that sample proportion goes here. The complement of it goes here. So the past study p hat sample proportion is known. If you are estimating a true proportion, again, they label this formula the proportion formula, but this time the sample proportion is in fact unknown from a past study. Or maybe there is no past study, it's just unknown. So in that case, you're going to make this assumption here about this p hat. You're going to assume now p hat is 50% or 0.5, which means the complement is also 0.5, which means the product is 0.5 times 0.5, and you will find that product turns out to be then 0.25. So there's the 0.25 here. And that's when the sample proportion is unknown. And there you go. So if you're going to do a new study, and the study is going to be about estimating a mean, mu, estimate a mean, this is the formula that you're going to use. Now, every one of these settings involves a confidence level, which means it involves that z alpha over 2 value for two tails, because this is estimation. Estimation is always two tails. And then they're going to give you a margin of error that they want you to be within that E, margin of error. So these are the formulas that you use here for a new particular study. And ladies and gentlemen, we're going to get to some examples. But this is about estimating the sample size now. Okay? So for example here, and we're going to go back and say, okay, we're going to use those. These are z alpha over 2 values. So they're going to give you a confidence level. We're going to need a z alpha over 2. Of course, this is working backwards. And I suggest you guys learn how to read your z table forward and backwards, since you're using it a lot. And you don't want to procrastinate. This is a two-tail situation representing the 99% confidence level. So remember these values here. These are my z alpha over 2 values. and that's the minus z alpha over 2. And that was found by taking 99% and dividing by 2 here, because this is the percent of the bow that's shaded in red, which will be 49.5%, 0.4950. So you found this in the past by using this Z table here. And working backwards, 4950 is here. They're telling you that. Here's that Z value there. So, ladies and gentlemen, I'm not going to go through all of that detail again since we've done it before, but I just want to say to you that this is the Z alpha over 2 value associated with the 99% confidence level. Now, similarly, for the 95% confidence level, you may recall half of 95% is 47.5%, which is 0.4750. So we're finding this value working backwards on the Z table. What we're looking for is 47.5%. So if you remember that particular way, working backwards, and it should be in your notes, we've done this. 47.5%, again, they knew you were looking for it. That was in the 1.9 row, 0.6 column, working backwards. So 1.96 is the Z alpha over 2 value, and minus 1.96, and that's what we're going to use for the 95% confidence level here. Okay, so this is where they got those numbers, 1.96 here. Now you might say, okay, what about the 90% confidence level? For the 90% confidence level, they got these Z alpha over 2 values. So you have these two values here. How they got them was to take 90%, you divide by 2, you get 45%. This is 45% here, which is 0.4500. So that's 45%. So if you go back and you look for 45%, remember for two tails here, 45%, they know you're looking at it, it's right here. They know you're looking for 45%, it's in the middle there. And they even tell you, hey, if the area is 45%, that z-score is 1.645. So this is just working backwards with your tables, and that's why this is a 1.645 and minus 1.645. So you have these important z alpha over 2 values. And that's what you're going to care about, these z alpha over 2. This is for two tails. Estimation's always two tails. Now, let's read the question. They're going to say, a new study to estimate the true proportion. So, okay, we're estimating the true proportion of people who are left-handed in California is going to be conducted using the 90% confidence level. And when I see 90% confidence level, I draw a picture here of a normal distribution. There's 90%, and you're going to have these z alpha over 2 values that we found. So remember, that's your z alpha over 2 minus z alpha over 2. We found them in the last example. So they're going to now tell me, here's my question here. So that's an important detailed information. You're going to want us to estimate the sample size needed, that's n, to be within a margin of error of really plus or minus 2%. So I'm going to write this down here. The margin of error is really going to be between plus or minus 2%. They just say 2%. And 2% as a decimal is 0.02. So Here's your margin of error. So now you say, okay, what does this say? The sample proportion from a prior study is 9.5%. So p hat from a prior study, 9.5% is 0.095. So I'm going to use this, and remember what q hat is. It's 1 minus 0.095. We're going to find that value too. So in the TI now, 1 minus 0.095 becomes 0.905. So we're going to use this value too. So don't forget the margin of error formula. This is known. We know what p hat is, and we know the complement here. So this portion's known. So your margin of error formula, remember, go back, it's known. It's going to be formula number 1 here. So I'm going to get rid of all this colorful information because it's going to distract us. It's going to be z alpha over 2 squared times that p hat q hat. This is what I'm looking at. Over e squared. Z alpha over 2. That was e squared. I believe that's squared. Let's double check. Yes, it is. Z squared. And then p hat q hat. They just put this in parentheses, and so we will do the same. And so plug in the values here. This first value, we already know what that is. That's 1.645. My margin of error is 0.02. We know what that is too. That's down here. So that's 0.02. It's 2%. P hat over here. And Q hat. 0.095, and this is 0.905. So all together here, E will be 1.645 squared over 0.02 squared. And it's going to be times 0.095 times 0.905 here. So that's going to be what we get. We're going to, and that's not margin of error, that's going to be sample size. So that's the sample size needed. Sorry about that. It's not an E. That's an N. So we're going to punch this in the calculator in the TI. Here we're going to punch that in. So now we say we have 1.645 squared. Now I might say to you, put this in parentheses. 1.645 square that. Divided by, now E is 0.02 square that. So that's in parentheses. That's my z alpha over 2 squared divided by E squared. Now we're going to multiply times the sample proportion of 0.095 times 0.905. And ladies and gentlemen, you're going to round this value to the nearest ones position. Ones position. The 1 is in the ones position. The digit to the right is a 6. That means add 1 to 1, and this is going to be 2 there. So it's 582. Now, this is the minimal sample size needed, and this is how they write the answer. N has to be at least 582 data values. So you would gather at the very least 582 data values. So that's how you do this, ladies and gentlemen. You plug these values in your calculator and you know, get the minimal sample size. Now, compare this example to the next one because they're saying estimate the sample size needed, that's n again, to be within, it's the same margin of error of 2%. Now, notice what they're saying here. The sample proportion from a prior study is unknown. So when the sample proportion is unknown, we get rid of the prior information. There's no prior sample proportion. We assume p hat is 0.5, which means the complement is 0.5, which means the product is actually 0.25. So that portion now gets replaced with 0.25. So you say, what portion is that? Well, right here, we're going to erase this. This portion, by formula, is 0.25. So we get rid of that. Multiply by 0.25. That's going to give you a different sample size. So if you go back and you said, well, which formula was that? That's formula now number 2 here, just to let you guys know. Right here. Formula 2. And this is where they get this 0.25 factor. So, ladies and gentlemen, go back and punch that portion in and see what you get now. And we're going to go to the TI. So we get, again, in parentheses, 1.645. Square that, divided by 0.02, square that, close the parentheses, times 0.25. And now, ladies and gentlemen, approximate again to the ones position, the nearest ones, and that's going to be 1,600 in, well, actually, what we do is we round up. We don't approximate to the nearest one, so round up, because this is data. So round up to the next whole data value, 1692. Round up, ladies and gentlemen. We'll put that in our notes. Since this is data, we need to collect, at the very least, 1,692 data values. So that's going to be the sample size that we need. Round up. Let's put that in our round up. So we're going to need at least this much data, 1,692. Now you can gather 1,695 or 1,700 data values or 2,000 data values. You don't need to. The minimum sample size you need is 1,692, rounding up, because this is data. Again, there's no such thing as a decimal data value, and you just round up to the next whole number. And that's how you handle the situation when there is no prior study of sample proportion that is known. So the next example is a social media gaming app. And let's say you're going to develop a new social media gaming app to be advertised on Facebook, and would be conducting a survey using the 95% confidence level. So determine the true proportion that favor the app. So again, this is a true proportion P. We're going to estimate P, proportion who favor the app, and this is for a new study. So again, it's the estimated proportion. 95% confidence level, if you guys remember. Those Z alpha over 2 values for 95%. This is Z alpha over 2 and minus Z alpha over 2 for 95%. We're going to use that. And so they're going to say again, estimate the sample size needed, estimate N, this time to be within a margin of error of 3%. And sometimes they say plus or minus 3% for, as you guys can see, a new study. Now, notice they do say, in the past version of the social media gaming app, it had a 52% favorable opinion. So the sample proportion was 52%, which is 0.52. Now, the complement of that is 48%, which is 0.48. So we're going to use that. Now, the formula, again, for estimating the sample size is that Z alpha over 2 squared over E squared sample proportion times the complement of the sample proportion. We're estimating N right here. So let's plug everything in. 1.96. My error is 0.03. P hat 0.52. The complement 0.48. So we can see everything here. And let's just write N 1.96 squared 0.03 squared times 0.52 times 0.58 or 0.48. So let's enter this in the calculator. Again, parentheses, 1.96 squared divided by 0.03 squared, close that, times 0.52 times 0.48. So round to the nearest next whole number. So N, when you round up, is 1,066. So we can also write this as saying if we take a sample that's at least the size 1,066, using the 95% confidence level in the new study, we will be within a margin of error of plus or minus 3%. And this is how we answer that question when the sample proportion is known from a past study. Compare that to question 2 that says estimate the sample size needed to be within the same margin of error of 3% for a new survey. If the past version, what do we know? If the past version of the social media gaming app is unknown, meaning the favorable opinion. So for the favorable opinion here, it's unknown. So sample proportion is assumed to be 0.5. The complement is 0.5. And so this particular product, by the formula we get rid of, we multiply 0.5 with 0.5, we get 0.25. So this is the second formula here. And this is unknown favorable opinion, just to keep that consistent. Okay, so this is what they mean, just to keep those two statements the same. So just change this factor here to be 0.25. And that will change the sample size. Now notice in the last example, it was, favorable opinion was 52%. Now we're assuming it's 50%. So it's going to be close. 52 and now 50%. So it's going to be close. It's only 2 percentage points difference. So let's try this out. 1.96 squared divided by 0.03 squared. Close that times 0.25 here. Now, ladies and gentlemen, as I said, 50% was close to 52%. The minimal sample size now, rounding up to the next whole number, round up, is 1,068, rounding up. So n, you can write it both ways, has to be at least 1,068 data values. So, we're using the sample size formula, estimate the sample size formula. We solved, we took the margin of error formula, solved for n, and now we have a nice formula to estimate sample size. Okay, this is another new study, female college students. So in a new study, on the mean, oh, look at this. In the new study, look at this particular study. This study, you're talking about a mean. So we're going to estimate in the new study. We're estimating a new mean. And it's going to be conducted using the 99% confidence level. So if you remember, for 99% confidence, this is my z alpha over 2 and minus z alpha over 2 for 99% confidence. So they're going to say now, estimate the sample size needed for the new study to be within a margin of error of 0.5 years. 0.5 years. So that's your margin of error, 0.5. So you go, oh, okay. E is in a half a year. That's the margin of error. Now, they also say having a standard deviation now. That could either be from a sample or just the past population standard deviation of 12.2 years. And again, that's from a past study, so that's going to be S. So sometimes they give you sigma, and sometimes they give you S. And it's not as clear. It's from a past study, whatever. Doesn't really matter. This is from a past study. So if we look at the margin of error formula now for estimating a mean in a new study, because they told us a new study you're going to estimate a mean, we go back and we look at the formula here. It's formula number 3 here. So to estimate a mean, it's going to be z alpha over 2 times sigma divided by the margin of error, and everything is going to be squared because that's the formula. So we're going to try this out. Z alpha over 2 sigma over E. You write it down. N is Z alpha over 2 times sigma divided by E, and you're going to square that. Raise it to the second power. 2.575 and that's for my Z alpha over 2 value. Sigma here is 12.2. They gave us that. And the margin of error they gave us to be 0.5. So altogether, to estimate the new sample size, we have N is 2.575 times 12.2 over 0.5, and then everything is raised to the second power. So we're getting all the information here. We're going to punch that all in the TI calculator. So we're going to say parentheses 2.575 times 12.2 divided by 0.5. Close that. Then you raise that to the second power now. So you're going to round this up to the nearest whole number. So now N here is approximately 3,948. So the minimum sample size needed, you need at least 3,948 data values in this particular study here. I'm going to round up that data. So, you go out and gather that kind of data, 3,948 data values for this estimation of the mean mu. So as you can see, you're just going to plug in the values. You're going to read it, and you're going to plug everything in you need and round up. Here's another new study on the mean IQ scores of college professors. So the estimation here in the new study, you're going to estimate mu, because they told you estimate mean. And they want you to use the 95% confidence level. So when you draw your bell, 95% confidence level, your Z alpha over 2 values are going to be 1.96. So I'll label that because it's important to know. Now what they say, estimate the sample size needed to be within a margin of error of 2.5 IQ points. So E, the margin of error, has to be within 2.5. It's really plus or minus 2.5. And then they say, well, using a standard deviation of 15. So that's from the past. So the margin of error formula, N, again, is Z alpha over 2. Or not the margin of error formula, sorry, estimate the sample size formula, times sigma over the margin of error. Raise that to the second power. So this is N, you're estimating the sample size, ladies and gentlemen. So don't forget 1.96 for the Z alpha over 2, 15 for the standard deviation. Your margin of error is 2.5. So we just plug it all in. So the sample size that's needed will be 1.96 times 15 over 2.5. Make sure we square that. So you're going to use that formula. Parentheses, 1.96 times 15 divided by 2.5. Close that, raise this to the second power now. So round this up. 138.29 rounded up. 138.29 is approximately 139. So the sample size that you need is 139. So you would start a new study with 139, at the very least 139 data values. I wouldn't go any more than 139. Maybe I'd do 140, but I'll still be within the required margin of error. So there you go. So here's another new study, years in college. How many of these do we have? Is that the last one? Okay, here's another new study. New study on the mean number of years. Okay, there's going to be estimate the mean. So it'll be estimate mu. So we want to estimate the mean number of years to obtain a bachelor's degree using the 90% confidence level. So remember, this confidence level is 90%. So we have our Z alpha over 2 values. And that's what that means. It's going to be Z alpha over 2 minus Z alpha over 2. So you want to use those values. They're going to say to estimate the sample size needed to be within a margin of error of 0.8 years. That's not even 1 year. Okay. E is 0.8 years. And they say to us, while using a standard deviation of 1.8 years. So sigma would be 1.8. So if we're estimating mu and we want to estimate the sample size, we have to use the formula Z alpha over 2 times sigma over E, everything raised to the second power. So just plug your values in. 1.645, 1.8, the error is 0.8. So sample mean will be 1.645 times 1.8 divided by 0.8, raise this to the second power. So this will all be going in our calculator. Now double check here. Z alpha over 2 value, standard deviation, margin of error, and then you're going to square that whole thing. All right, let's try this out. Let's see what we get. So let's go to the TI. Clear. 1.645 times 1.8 divided by 0.8. Close that. Raise to the second power. Hit enter. That's a small sample size. This is an odd question. You need about what? Rounding up, you need 14 data values. That's weird. Anyway. Should be a large sample, ladies and gentlemen, but at this point of the night, I don't really care. We did everything the way it was supposed to be. Maybe they want a smaller margin of error. Who knows? Whatever. So, ladies and gentlemen, this is an odd one to end on, but it doesn't matter to me. So anyway, ladies and gentlemen, this is that video I promised you on estimating the sample size. So take a look at these questions on your homework, and you should be fine. Just do it the exact same way. It's going to be these confidence levels, 90, 95, 99%. They might throw a 98% just to keep you awake, but that's okay too. So here's the video I promised, and enjoy. Take care. Have a good evening.